Hello, Andy Kettle here once again from Server Components and Systems here in the UK. This video is going to run through how you can reset a Copley controls amplifier after you've removed the high voltage supply to it, assuming you've got a separate supply to the auxiliary to keep the processor running, or using CME2 every time to reset it, or indeed recycling the power to the drive. So here you can see the hardware that I've got. We've got a BEL Copley drive connected to an EtherCAT motor and an absolute encoder. You'll see that we've got the Safe Talk Off link made for this demonstration because we're going to show how you remove the power and reapply it and reset the drive and continue as if nothing had happened. So why would you want to do that, I hear you ask? Well, the normal way of shutting down a drive in a E-stop situation would be to remove the Safe Talk Off. That removes the power to the output FETs, making the motor safe. However, not all drives can do that, and some designers prefer to remove the voltage altogether from the drive. But it really depends on you and your application. So if you do use the latter solution, then I'm going to show you how to reset the latch over the serial comms, but it could equally be done over CAN or EtherCAT. So to begin with the both supplies connected, that is the auxiliary to run the processor and the HV plus to run the power stage and the motor power, we're going to go to the control panel here and just show that the motor does work. So we're going to enable jog. Watch this here, you'll see if I now jog it positive, the encoder counts will increase. Now while we're doing this, we could remove the power, but first of all let me just go back and we'll check how we've got the faults configured. Now if we go to configure faults, you'll see there are a whole range of errors that we can latch. At the moment we've got under voltage latched, so I'm going to undo that for the moment, just for this demonstration. Go back to control panel and jog it. And while we're moving it, I'm going to remove the power. Now, you'll see no error. Well, it flashed up very quickly under voltage, but then it went away again. But you'll notice at the bottom, the amplifier in red is saying amplifier disabled. But because we haven't latched the fault, and the motor's now not moving, you'll see the error has actually disappeared. And if you weren't watching it at the time, there's no way of knowing what caused it. So, if I now reapply the power, like so, you can see that we can continue again without any problem, and no resetting is required. Just to do it in the negative direction, if I remove power again, there you go, flashed up under voltage, counter stopped, and the amplifier is disabled. Now, I'm going to reapply the power, and this time I'm going to go back and configure the fault to latch under voltage. Okay, do the same thing again, control panel, enable the jog, and jog it. This time I'm going to remove the power, and this time you'll see that the under voltage latch has remained on the screen, amplifier is disabled. Now, even if I reapply the power now, and continue jogging, you'll see that nothing happens. Okay, so we've got to clear it somehow. Now we could use CME2 and press the clear faults, which I'll do now. Error goes away, enable the jogging again, and you'll see we're off and running. But of course, if you've got a system running in the field, you don't want to load up CME2 every time to clear the fault. So how do we do it? Okay, so what we're going to do now is recreate the error again and jog the motor and remove the high voltage. And you can see we've got the under voltage latch fault there. And now we'll go and reset the drive using the Ascii command line editor. So if we go to the Copley website and load the parameter dictionary, you'll see a table with addresses in it. First column is for Ascii. Second column is for the CAN and EtherCAT. We're going to look at, first of all, address XA0 to find out which bit is which. We're looking for under voltage, and we can see that bit 3 is the under voltage, and in hex 1248, so 08 hex would clear it. The bit we need to clear is in register XOA1, which is the event status register. So here we would write to XA1 080, and that would clear the status register itself. But we also need to reset the actual latch itself, which is in, you can see there, 04. And just to make things difficult, it's actually in a different bit. It's in bit 6, as you can see there. So that's 1, 2, 4, 8, 16, 32, 64. So you'd write 64 to A4. So we'll now do that using the command line editor within the CME2 environment. You'll find that tool under Tools, Command Line Editor, and the instructions on how to use this is also on the Copley website. So when I enter that, we come up with a command, and so to clear the status, we've got to do set register 0xA1 to 8. Okay, and then we've got to do register 4, which is resetting the latch, to 64. Okay, close that. Now if we go back to the control panel, you'll see the fault has gone. We can enable the jog and carry on as if nothing had happened. So that's what you do. Thank you for watching. I hope this was useful, and we'll see you next time.